Hello, let's continue our Sudoku adventure with Game of Roses by Emphyrio. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have arrows in the grid. Let's take a simple one here like this. So there's an arrow, and it's attached to a circle. The digits on the arrow sum to the value in the circle. So if I make this, say, a 5, then these two sum to 5. We could do, say, 2, 3. So this would be one way to fulfill that arrow. Also do 1, 4, 5, or we could do 2, 4, 6, etc. Now, if you have two different arrows coming out of a circle, those are just different arrows. They happen to share a circle. So if this was a 6, this could be 2, 4, and then this could be 1, 5. Or this could be 2, 4 this way, right? We just have to fulfill that both of these end up adding to 6, or adding to whatever this circle is. And additionally, arrows don't prevent you from repeating. Sudoku does, but arrows don't. So we could, for example, do 2 plus 2 is 4 here. That would be fine. We can't do 2 plus 2 is 4 here, but that's not because of the arrows. That's because of Sudoku. Sudoku doesn't like repeat in a row or the box. So yeah, those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. My eye is drawn to this one here because it's got 2 arrows coming out of it, and these share a box. So if you want to think about this, the first thing to realize is, let me just color this so I can just talk about the cells. The green cells, when you add those together, that equals blue. And the purple cells, when you add those together, that equals blue. So green plus purple is 2 times blue. So if we know what green plus purple is, then we can divide that by 2 and we can get blue. So those are some very good properties that we can use. So for example, we know that in this box, the minimum of these 3 cells is 1 plus 2 plus 3, which is 6. And the minimum we could put in this cell is a 1. Just in isolation, not thinking about anything else, that would be the minimum we could do. And so that would add to 7. But we know that green plus purple is going to be even because it equals 2 times blue, which is it's just an integer. So doesn't mean blue is even. It just means green plus purple is even so that we can evenly divide it by 2 to get blue. So this actually is minimum 8. And so 8 divided by 2 is 4. This is at least 4, which isn't as restricted as I hoped, but there you go. We got a restriction on it. Now, we always want to think about it individually. Can this really be a 4? That would force this to be a 1, 3. And unfortunately, this could be 2 plus 2 because we're allowed to repeat. So because this exits the box, we are definitely allowed to do a 4 there. Okay. And in fact, that ends up being the minimum to get to 8. Anyway, what else can we do? We could combine these together. I don't think that's useful, though, because that's 7. And these two, like this is already going to be at least 3. And so these are definitely going to add to 7 no matter what we do. So that's not going to be helpful. Over here, though, these add to 10 at least, because 1, 2, 3, 4 is all in the same box. So they could be 1, 2, 3, 4 adding to 10. So this can't be a 3, because then this would have to be a 7. 7 doesn't exist. So this is from 4, 5, 6, and this is from 4, 5, 6 in order to get to a minimum of 10. It could add to 11, could add to 12, but it can't add to 9 or fewer. So this has to be from 4, 5, 6. And then in this column, these add to at least 10 also. So this also is a 4, 5, 6, because these two add to 10 or higher. And here, no, that's 7 again. So this is just from 3, 4, 5, 6. All right, now we have minimums for all of our circles, and we have some good relationships. These sum to at least 10, and these sum to at least 10. Oh, but let's give this a color. Let's give this green. The question I want to ask is, where does green go in this box? Well, it definitely doesn't go in these 2 cells because that would share a column. Now, when I say where does green go, I mean whatever value ends up in the green cell, we'll call that green. Green might be 4, green might be 5, green might be 6. Actually, I'm about to prove that can't be 6, but whatever value it is, that's going to go in this box, right? Because this box has all 6 values. So it's going to have a 4, 5, or 6 in it. So which one is the same as green? Well, definitely not repeating in the column. We're also not putting a green on this arrow because then we'd have to pair it with a 0, which it doesn't exist, in order to add to also green, right? Because it's 2 digits adding to green. So that puts green on this arrow. Now, if green is on this arrow, that means it's pairing with at least a 1 in order to get this value. Let's call that purple. So purple must be bigger than green because green is on purple's arrow. So that means purple cannot be 4 and green cannot be 6. because otherwise we would what am I saying? Otherwise we wouldn't green wouldn't be less than purple. Right, that's what all I'm trying to say. If green was 6, then purple couldn't be bigger. If purple was 4, then green couldn't be smaller. That's all I'm saying. So these greens look down. That puts green in one of these two. Now I can't necessarily prove that this one's not green. Oh, but we do remember that these two add to at least 10. So this can't be a 4 anymore because this can't be a 6. So in order to get to 10, this is from 5, 6. It could still be green though. These could be double 5. What am I thinking now? Oh, well, what would happen if purple was 5? These two need to add to at least 10. So, but it would also force green to be 4, right? If purple was 5, these can't be the same digit because green is on purple's arrow. It's different than these. These could be the same, but these are definitely different. And if they're definitely different, we can't do 5 plus 5. So purple cannot be 5. Purple must be 6, and so we don't need a color for it because we know it's 6 now. Those aren't 6. Very nice. Okay. This is coming together. I'm getting it. Just need to think carefully about all these things. So, okay, so this is either 6-4 or 6-5. So that's to 10 or 11. That's fine. This could be double 5, I think. Okay, so these add to either 10 or 11. They can't add to 12 anymore. That means these add to 10 or 11. So what's the leftover? The column adds to 21. 1 through 6 adds to 21. If these add to 10, then the leftover is 11. These two would add to 11. So this would be a 5-6 pair. And if these add to 11, then these would add to 10, which would put a 4 here. This would be 6-4 only. Ooh. Yeah, that would work. This would be 6-5. And then this would be a 4. So if this is 5, could this be 5 with a 6? I think so. I got this 6, actually. Maybe I should think about that. 6 can't go on arrows. And because if 6 was, unless it's a 1-cell arrow, but if 6 was on an arrow, right? If 6 was down here, then what the heck would this be, right? We do at least 7. So 6 doesn't go on arrows, and this can't be 6. So 6 goes here. 6 looks down. It's not on an arrow. It's not on this arrow. So 6 is one of these two. 6 looks down. It's not on an arrow. Can I do more with 6? Well, 6 in this box is placed now. It's only here. And then 6 is in one of these two. This is not a 6 anymore. Interesting, because of this 6. So this is a 4-5 pair. Wow. Okay. Well, if this is a 4-5 pair, then that means there's a 4-5 pair down here somewhere. It's certainly not here. So one of these is 4, and one of these that forces 1-4-5, right? Because I need a 4 and a 5 down here. If the 5 were on here, we're not putting the 4 with it, so we'd have to do 5 plus -1 is 4. I hope I'm explaining this right. Hopefully that makes sense. But if 4 and 5 aren't here, they can't both go on the arrow, so the bigger one goes in the circle, and the smaller one goes on the arrow, and it has to join with a 1 to make the sum correct. So that's not a 5. This 4-5 pair came out of nowhere. So this is a 1 then. It's nice. So this has to be 2 plus 4, and that makes green a 4. Yeah, because this can't be 1 plus 5 anymore. So that's a 4, that's a 5, that's a 6, so that's a 4, and now we don't need green anymore. Nice. These aren't 6s. Places the final 6 in the grid. Oh no, we have one more 6 to place. It goes there. 4 plus 2, that's a 3. 4 is 1 plus 3. We don't know the order, but that does put 5 here. This is 1 plus 2. Well, this can't be 1 plus 2 is 3 if this is 1, 2. Did I say 1 plus 2? I just meant this is 1, 2. But anyway, this can't be 1 plus 2 equals 3, because then we'd have too many 1, 2s in here. So this is a 4, and this is a 3, and this is a 1. That makes this a 5. Yeah, these haven't resolved yet. How are we getting 5 here? And I'd say it can only be 2, 3. If we try to do 1, 4, then obviously there's a lot of problems with that. But I was going to say it puts 3 1 4s in this box. So this is, in fact, this is just a 2 3 pair, and then this is 2 3 a pair as well. So now there's no 2 on this 6. So this has to be 1 5 when we do the order. Because if there was a 2 here, we wouldn't be able to put a 2 on this 5 sum, right? Hopefully that's clear. So that's 1 and 5. That's 3 and 1. That's 4 and 1. Oop, deet. Excuse me. Now we just finished the puzzle. This is 2 or 4. Okay. This is 2, 3, or 4, not 4. So 2, 3 pair gives us the 4 here, the 2 here, the 4 here. This is known. This is a 1. This should be known as a 3. That gives us 2 and 3, and 3 and 2. And then down here we need 2 and 5, and we're done. Nice. Pretty intricate puzzle. I had to think about just the right things, but it seems like the key things to think about. I'm not even sure we had to think about this stuff early on, but we definitely needed to think about how these add to 10, at least 10. They ended up adding to 10, but these add to at least 10, and these add to at least 10. And how this ended up here. And then also how this ended up being a 4, 5, or 6. And then also, so we forced this to be 6 because this was on here. And if this was 5, this would have to be 4, and that wouldn't add up to enough, right? So that forced that to be 6. And then once this was 6, it does put a 6 here, which then now, if we think about how this added to 10 or 11, the outies here had to add to 10 or 11 also. And in order to add to 10 or 11, this had to be 4, 5, or 6, but it couldn't be a 6 because of that 6. So we got a 4 or 5 pair there. That's kind of crazy. Once we got the 4 or 5 pair, the final deduction was that this ends up a 5 and this ends up a 1, 4, and the rest came clean. That's pretty intricate. That's cool. I enjoyed that, Emphyrio. Definitely on the harder side for adventure, but I hope you enjoyed it. And if you did, then why not leave a like, subscribe, and a kind comment below.